You know, right now inside your engine, there could be a battle going on. A series of tiny, violent, uncontrolled explosions that are literally tearing it apart from the inside out.
And the crazy part is, the one little sensor that's designed to hear this happening, to sound the alarm, well, it might be completely silent. Your engine could be screaming for help, and the computer, your car's brain, can't hear a single thing.
So what is this destructive force we're talking about? It's called engine knock, and the reason your car's computer, the ECU, might be completely deaf to it is because its only ear has failed. Let's break down what's really at stake here.
Now, this isn't normal combustion. You see, a healthy engine has a smooth, controlled burn that pushes the piston down. Think of it like a firm shove. But engine knock or detonation is a whole different beast. It's a violent, spontaneous explosion. It creates these insane shock waves that just hammer your pistons, your bearings, all those critical internal parts.
The real problem here is speed. A single one of these knock events is over and done in just 1 to 5 milliseconds. That is literally faster than you can blink. There is no way a person could ever react to that, which is why your engine needs its own dedicated, high-speed guardian.
All right, so let's meet that guardian. It's the knock sensor, a pretty small, unassuming little device that plays an absolutely massive role in keeping your engine alive.
Honestly, this is the perfect way to think about it. It really is like a tiny, specialized microphone that's bolted right to the engine block, and it's precision-tuned to listen for one specific sound, that high-frequency ping of engine knock, while ignoring all the other normal engine noise.
So how does it pull this off? Well, inside that sensor is something called a piezoelectric crystal. It's a special material, and when that shockwave from knock vibrates the engine, it physically squeezes this crystal. And when it gets squeezed, it instantly generates a tiny voltage signal. So that violent vibration becomes an urgent electrical SOS message.
And this creates this amazing, lightning-fast defense system. The sensor detects the vibration, it sends that voltage signal straight to the ECU, and the ECU immediately retards or, just slightly delays the ignition timing by a few degrees. This instantly lowers the pressure inside the cylinder, and just like that, the knock is gone. The whole thing happens in milliseconds. It's a perfect loop.
But that entire beautiful defense system, it all hinges on one simple fact. If that sensor is broken, the ECU is completely deaf. It has no idea the engine is destroying itself.
So what happens when this guardian goes offline? What happens when your car's computer is forced to fly completely blind?
Well, you'll probably get a few warning signs. The most obvious, of course, is that check engine light popping on. You might also actually hear that classic pinging sound when you step on the gas. Or you might just notice the car feels a bit sluggish, maybe a bit weak, and your fuel economy starts to tank.
But here it is. This is the most dangerous part of this whole situation. This is the trap that costs people thousands and thousands of dollars. Your check engine light is on, but the car seems to be driving okay. So you ignore it. You figure, it's probably just some minor sensor thing. I'll get to it later. And here's the massive disconnect. From your perspective in the driver's seat, yeah, the car might feel a little lazy, but it's running. It gets you from A to B. But inside the engine, the reality is, well, it's terrifying. The ECU knows the sensor has failed, so it's gone into this emergency failsafe mode, locking the ignition timing into a super conservative setting. It has completely given up on listening for actual knock.
So what exactly is failsafe mode? Think of it like this. It's a blunt instrument. It's not a smart active defense anymore. It's just a pre-programmed, one-size-fits-all timing map that kills your power and efficiency just to reduce the chance of knock. But, and this is the key, it offers zero real-time protection. It's just guessing. If you get a bad tank of gas or you're towing something heavy and real knock happens, the ECU has no ability to correct for it. That defense loop is totally broken.
So what's the real price of ignoring that check engine light? What's the cost of falling into that trap of false security?
Well, the numbers pretty much speak for themselves, don't they? Replacing a knock sensor is usually a minor repair. We're talking maybe under a couple $100. But continuing to drive while that engine is just hammering itself to death, that leads to things like cracked pistons and destroyed bearings. And that's not a repair. That's a full engine rebuild. And you're looking at thousands of dollars.
You have to understand, modern engines are designed to run right on the very edge of performance to be efficient. The knock sensor is the safety net that lets them do that. When you take away that sensor's feedback, you've removed the entire safety margin. There's nothing left.
Okay, but the good news is just understanding this problem is 90% of the solution. And thankfully, the fix is usually pretty straightforward and absolutely essential.
This waveform you're looking at, that is the language of knock. That's the signal a healthy sensor sends to the ECU. When the computer sees this, it knows exactly what to do. But when this signal disappears, the ECU just assumes everything's fine, even as metal parts are being hammered into oblivion.
And if you've ever plugged a scanner into your car and seen this code, P0325, then this explainer is talking directly to you. That code means the ECU has already detected a problem in that sensor's circuit. It is the #1 red flag for this exact problem.
And one last, absolutely vital point. If you drive a modern car with a turbocharged or high-compression engine, this isn't just a suggestion, okay? This is an urgent warning. These engines are built to handle pressures that would have instantly destroyed older engines. They absolutely depend on a working knock sensor just to survive normal operation. Driving one with a bad sensor is a high-stakes gamble that you will eventually lose. So just remember this, that small, pretty inexpensive little sensor is the only thing standing between normal combustion and catastrophic engine destruction. Now ask yourself, is ignoring that little check engine light on your dash really worth a $5,000 risk?